Okay, so these are the example 2 triads. In the lesson last night, I did the example 2 examples. So these are 2 more examples, just to be thorough. It says expand logarithmic expressions. Use the properties of logarithms to expand each expression. When we were asked to expand a logarithm, that means we're going to be starting with a single logarithm, like you see in parts A and B here, and we're going to expand it to multiple logarithms that are added and or subtracted together. Right? Now the 3 properties are the power property, the product property, and the quotient property. So let's see how they apply here. Part A, log base 7 of r to the third times t to the fourth divided by v. Well, this is actually a pretty complicated example because we have multiple things happening. We have multiplication right there. That means at some point we're going to want to use the product property. We also have division, dividing by v right there. That means at some point we're going to want to use the quotient property. And we also have some exponents on the r and the t. So at some point we're probably going to want to use the power property. Right? This example is going to include all 3 log properties. Now the first one that we should apply would be the quotient property. And the quotient property is going to allow us to take that original logarithm and rewrite it as the log base 7 of the numerator, r to the third, t to the fourth, minus log base 7 of the denominator. This is the quotient property. All right, next, we can expand it even further because notice right here I have the logarithm of a product. Right there, those 2 things are being multiplied together. So I'm going to apply the product property to expand that logarithm. So I end up getting log base 7 of the first multiple, r to the third, plus log base 7 of the second, t to the fourth. And now I can bring down the minus log base 7 of v. And that all stemmed from the product property. Now the last thing is to take care of these exponents. That and that. Now the v has a 1, so we're not going to do anything with that one. The power property says that we can take those exponents and bring them down in front of the logarithm. So this would be 3 times the log base 7 of r plus 4 times the log base 7 of t minus the log base 7 of v. And that was all the power property. So we've expanded from this single logarithm now to this expanded form that is made up of 3 logarithms added and subtracted together. All right, example B, the natural logarithm of 7 divided by 225. This is going to be a much simpler example because we only have division, right? So that means we're going to apply the quotient property. We can rewrite this as the natural log of the numerator minus the natural log of the denominator. And that's all we can do right there. Just the quotient property. All right, example 3. Two more triads. Now it's saying write each expression as a single logarithm. So instead of expanding, we're now sort of combining the logarithms. We're still using the same properties. So in example A here, 5 times the log base 2 of c minus 7 log base 2 of n. Well, first thing I see is I see these numbers out in front. which I can move to the exponent of c and n. So it's going to look like this. Log base 2 of c to the 5th minus log base 2 of n to the 7th. Since I'm subtracting here, I have to recognize that the quotient property subtracts the two logarithms. So I can rewrite this as the log base 2 of the first c to the 5th divided by the second n to the 7th. Now keep in mind that all of this was doable because from the get-go we had the same bases, right? They were both log base 2. If those are not the same bases, you cannot even apply the quotient rule property or the product property. So we had those same bases. We were able to do what we did. We finished off with a single logarithm. Now part B. 2 times the natural log of 7 plus the natural log of 2. Well, I have this number out in front, that 2, so I can make that the exponent on the 7. So I end up getting the natural log of 7 squared plus the natural log of 2. I might as well square the 7, get the natural log of 49 plus the natural log of 2. Now, because this is a plus, I need to recognize that that's the product property. And so I can rewrite the sum of those two logarithms as the logarithm of a product, 49 times 2. And 49 times 2 is 98, so I can write the natural log of 98. So if I took out my calculator and I typed in 2 times the natural log of 7 plus the natural log of 2, I get some crazy decimal number. And if I took my calculator and I typed in the natural log of 98, I get the same number, right? What these properties allow us to do is manipulate how these logarithms are written, which can become useful when we have to solve equations with logarithms.